Foo could not be found. Okay, okay, okay. Yeah. Let's jump to this. So, probably gonna need my glasses, wherever I found them. Well, put them. Sorry. They seem to be gone. Okay. Let's. The black background is bad for my astigmatism, but I'll have to make do. So, what in a place in the compiler, we're gonna handle the global generic modules. Generic module. So this is where we analyze them, but that's not the one I wanted to do. Here is the generic module list. Sorry about that. So here we are. Here, look at here, this. So we're gonna find or create a module, and it might have, parameters, but what it does is like, okay, I found this module with the parameters, and so now let's just kind of, I don't know, ignore that, even though it might have some other arity. And let's see how this is called. Okay, so it's called, so we have the parameters. Oh, here we have check name, right? So now we know about the parameters, but we also have, let's see, where we are creating one here, and we're creating another one here. Does it even use the parameters? Probably does. Let's see. So let's see. Okay, if it's if the parameters is null, right? Then it's, we can check if it matches the module's generic, so it's both a regular and generic module. In the other case, okay, so the module name here did not match the actual module. I wonder when this happens. In any case, so we did find and create the module, right? And now this is not quite correct. So if the parameters, if it's a generic one, right? It's a generic one, we need to handle this. So actually, we need to handle it like this case as well, but we need to look at this first. So if it is generic, and now this is going to be like very ad hoc. Didn't I do anything nicer with this? So let me just have a look at how these parameters appear, because it's it's just not nice to just get strings. It's nicer if you get something like identifiers, identifier expressions, but maybe it just has this. So we're gonna, here we have the generic parameters. Where is this? It's parsing the module. And so we get the generic parameters, but they're just strings. We could probably do better things with this, but it is what it is. Okay, so at this point, we know that these parameters are going to be like either it's a type identifier or it's a constant style. You can't do anything else. So we have the case where the parameters are null, right? So then we can go to this error, right? We can just put this error somewhere else. Let's use go to print generic non. Oh, that's fine. So one more thing, I'm going to like allow using both. So okay, so let's go back here for a while. Right, I want to make a difference between generic and normal modules, right? And let's see how this works, right? It's going to add itself. It's going to look through the modules. Like, look, let's find the module, and it's going to look through the modules. Yes, it's going to say the module name there. But then I would like it to be possible. This is not ideal. So, because we want to have both. So maybe in this list here, right now, what we get back is a module. But we could get back, how does this H table is assuming there's a pointer, just a pointer. This is not so nice. Oh, wait, I have an idea. So we could always have like a module. The module itself could always point to its generic version, right? Then it would just have a pointer to itself. No, like the pointer to the next one. So well, let's take, it's like, it's either a generic I don't know why I optimize this like this. Well, anyway, so we get a sub modules, parent module, generic module. Oh yeah, the generic module is going to point to the original module if this is an instantiated one. But we can do if it's not generic, it's generic. Hang on, let's see how we instantiate that one. So we set generic false, right? And then we'll have generic module. So module generic, what do we call twin module. I can't come up with a good name right now. Okay, so let's see if anyone has a question. Well, no. Hello. Hi. Okay. So now we get the module, right? And if we have parameters, if we're gonna get the non, we're gonna make like the normal module, and we're gonna make the generic version of the module. So if we have a module, and then we can, yes, okay, so it's there, right? It's a module. Now we have two options, right? If it's the module itself has a generic twin module, then we return okay, and it's if it doesn't have any parameters, then we just return the module. Otherwise, we let's comment this a bit. So no, that's not commented. Let's try to make it obvious. So okay, no parameters, return normal module. So if there's a parameter, and we have that one, we will return that. Generic module, generic twin module. Okay. So if we don't have one, then in the case of if it doesn't have any parameters, so we're gonna need to create the normal module always. And what's that gonna look like? So regardless, we're going to do this, right? So let's pull that out in a function, which is going to be alive. So create a module, create. Let's see what we want to put in there. So we're going to return a module, and it's going to have like a path name, right? So, and that's the module name. So, and then we have like a module, which is going to be like and then we're just going to have like, it's not going to have like parameters. It's going to have, okay. So right, but this is not going to, let's not do this part, right? All right. So instead we want to create the module. So we have like the module. Module equals module create. Take the module name and the parameters, which is going to be null. We're going to have null. Right? Okay, so now we have that one. So we're going to set that one in here. We're gonna oh, this one has to be go up here. We have to have a symbol list for the module. But okay, so now we're going to set the name here for this module, set the module to that, the non-generic module. Right, and then if there are parameters, if there are no parameters, so this is going to add this one's going to get added here, and otherwise we go to create generic module, something like that. Now this one should be the module. I didn't think straight. Right, so okay, so oops. If we are done, we set that, and we set that to the module. Okay, so what happens? We go in here, try to find the module. If we find the module, if it doesn't have any parameters, we return the module. Otherwise, we try to return the twin module if it exists. Otherwise, we're going to go to generic module. Now we get out of this. Now we know we don't have a module, so we're going to generate the normal module here and add it to the module list. And this module list might be, this is what you can generate later on. It's convenient to have it like that and not in the hash map. So okay, so once you're there, you're going to end up like, okay, it doesn't have any parameters, then we're done here. So we can just return the module, right? Otherwise, we go to create generic module, And then we need to create another module. So we are going to create our generic module, and we're going to do that. We're going to provide the parameters. Now apparently I set it wrong here, so we can have like 2, right, like that. So we're going to add the parameters, and we need this, and we are not going to set that. Instead, we already have the module, so we can set the generic twin module there. And then we're going to add it to a list of generic modules. And it's going to be a generic module we're adding to that list. And now we are done, and we can I don't know if this will work. Okay, but we are going to return the generic module anyway. Okay, so now that we're doing this, then there's like the parameterized. There are other ways that you get to instantiate this one. You instantiate a generic one, then you do some special stuff, but you create it without parameters, so it should be okay. Okay, let's see. We're gonna create that. Let's see the usages again. It's mainly coming in here, and now we're getting the module, right? And it's gonna be like either there's a match or there isn't. And if there's this is not going to apply, but what is going to apply is that if there are parameters, in that case we want to check that they are matching, right? So we do a for each index name and over the parameters. So if the module, so we can kind of know that something is a constant, right? So a string is valid lowercase name, no. Is a valid module name, no. Let's see where we have all these helper methods. As no uppercase is valid, is blah blah blah, is valid name, is type. Yeah, that's good. Let's check that. So str is type. If that one is a type, the name is a type. Is type. F is type, and module parameters idx str is type. Str is type. Thank you. And these are not the same. So there's a let's just put a to do here for now, right? We're gonna hit this one, right? But there might be other errors, so I want to deal with those instead. So in this case, let's see what happens. Okay, so if there is no module, it doesn't match another real module. Okay, this is kind of awkward. Let's see here. So okay, so if we have that module, okay, so that's the way it's going to be then. Okay, so let's see what happens. I think like a lot of things will just blow up when I do this. Right, here we go. So okay, so first of all, the arity must be the same, right? If vec size parameters is not the same as vec generic size module parameters. In this case, we can just say to do. Right? Let's say to do. Let's see if you wrote anything yet. No questions. Everyone is silent. Oh, look, the to do is reached, right? So in this case, we have two definitions that they don't match, right? So so maybe we could write something like, here's like the printer at, right? So return printer at, the new place, which is the module name, right? So no, printer at should be printer at generic module of the generic modules argument parameters do not match module the parameters of the generic module doesn't match note. This is a CMA error, right? CMA error, CMA note. We're gonna have like the old module. It has some span or some definition. It has a unit, right? So it has units. So let's go to the first unit of that one. And wait. It should have a definition name, like that, right? The definition is here. And I'm going to return false. Right. And then there's the other case, right? So okay, I'm just for now let's see what happens, right? So the parameters of the generic module, another definition is here. Okay, right? So that's almost what we wanted, right? So it's pretty much what we wanted, actually. So that works, but now I want to extend this and kind of allow this, right? So we're gonna allow foo, it's just gonna have some in now, right? So now we're gonna have two of these, and we're still gonna be able to, we still want to be able to do, this, right? And we're still going to be like, okay, foo x. Yes, and then we have this one, right? So something like this. This we want to be able to do this. So let's see what happens. Okay, so right now we get like dozens of errors. So this module is blah blah blah. Do you mean list? Okay, so right now we kind of get into some hairy stuff. Right now we're getting into the hairy stuff. So what is like this? Did you mean destruct? Okay, so what it's going to do now when it gonna look up things is the old code doesn't assumes that this doesn't happen, right? It's going to look into this list. This is going to do a lookup of this, right? So we're gonna do a find module here, and this is going to find the module, like the first one, right? We that's the one we use here. But if you use the parameterized identifier here, now we're kind of we're in a balance here. So we gonna look at that. So this is how you process the import paths. So okay, did you find it? If it's an import module. So let's look at that thing when you look it up. So we're going to look at the operator in module. Okay, declaration. Okay. Module include. So here things get gnarly, right? So you have this, and then if the import's non-recurse, now you're gonna look at that. If import module generic, then we're gonna have like and import module generic twin module, use module, then return true. And we need to do like this. So okay, hang on, module inclusion match. Right, so that one is going to be fine. Right, it's okay, it's generic. Now that's this one is okay. So if now it's going to be different. So if import if want generic, then yes, import like this. Not module, then we'll continue. So then we can ignore this. Is it private. Now we have the module. Do we do anything else with the module? No. Okay, declaration is visible. This is kind of awkward. But I just want to see, like, is it possible to solve it? Oh, what did work? That's weird. That was not what I was hoping for. Okay, let's see. Okay, so we should probably we don't want to look at these imports and find an operator in the module. Right, let's see. I don't think if it's a generic, right, is going to return null. So we are, this is fine, right? We don't need to do this. We can assert now module is generic. So this could never be true because we're not even looking at that. So let's see here. Here we are grabbing the right one, the one we want. And there's like this SEMA is path found, right? And now we're going to do something similar. So if, so the actual module, let's put the module, we change that one. If it's, if one generic, let's see, what is this? What is this? Find decal in global. I don't know if this is correct, so maybe I shouldn't mess with this one. Let's see what it does. So okay, path is found. It's just used in one place. So I have a module list. Where does that module list come from? So I have a list of modules, and they could be generic modules or regular modules. Then we're fine. Okay. So this seems kind of okay. So now we had hit that one, right? Let's see here. So if we are in a module, so we are in a module. We're gonna look at the submodules. So what kind of submodule are we looking at? We are looking at the one, this is the math, and we're fine here. So we're looking at the matrix ones, and so somewhere here we have the submodules, which seems to include the real modules. Okay, let's just let's kill this one, right? So I feel uncomfortable with doing that. I have to understand why the heck this one is part of the submodules. Let's see how the submodules are built, right? So we are adding to that. We're going through the module list, right? And we're going to add the submodules. But then one submodule. We're going through module lists. So how can we get a submodule that is a generic module? What about this here? Let's see where we get that. So let's make a assert that the the module. So the module here, it shouldn't be. Oh wait, that will happen. That will happen. Sorry, that will happen. That is normal. That's quite normal. So then we need to add this actually. If module is generic, then just return false, then return null. Okay, that makes sense. That makes sense actually. There's a case where we create a generic module. Also want to know what the parent modules are. Okay. Let's go back to wherever we were using this list of things. So we were here and we wanted to, let's see, here we wanted the module, right? So we import module. I'm just going to look through that again. So is there some other case when this, so it's like here we're going to resolve the symbol in a common way. We're going to look through the module list, so that means we can't get a generic module, and then it's going to have like, okay, we're going to get the modules, now we're going to get the parent modules. Do we have a match? Okay, we have a match, and then we might have a generic module. So now the question here is like, now we are not going to get this because this can never happen now. This thing, because we are always going to create a module that has the same name. So there's going to be like a non-generic version, and that means it's going to like be okay. There are going to be like weird stuff happening. Some weird stuff. Maybe I shouldn't do this. Maybe it's bad. Maybe it's a bad thing. Because what happens is that like what happens if you do for, right? So kind of treat that one as a generic thing, right? Something like that. So now we get like foo cannot be found. Did you spell it right? And that is completely weird. And that will be similar if I just do this. Again, it will say like it couldn't, I think like the foo1 could not be found, right? Did you, okay, so in this case, did you mean the struct foo1 in the generic module test2? If so, use foo1 instead. Maybe we could do like that. So foo could not be found. Did you spell it right? Then we need kind of something here. Let's see where we got that. I think it might be here, right? No, that's not it. That's not it. Damn it. That's not it. Maybe here. Path name. No, path name. Right, so it should be here. Feel free to ask questions. Feel free to ask questions. So now we're going to, we're going to try to resolve this. It's get it in the global. It's like, we don't need to have like, now we don't need to do differently for the parameterized ones. Because they are the same. So if let's say let's see what happens here, right? So the first step is kind of going in here, and then that's fine, right? And then we go the second time, and oops. Okay, let's run without standard library. That's going to be like much simpler to understand. So let's see that we don't use anything from the standard library. We don't. So here we go, right? We go there. 1, 2, 3, 4, 5, 6, 7, 8, 9. How many parameterized things do we have? Do we really do this without standard library? Maybe it's just I forgot about it. Yeah, standard library is included. Okay, so use standard. I think it's like that. No, something like that. I keep forgetting the settings. It's really embarrassing, but that's the way it is. And now I have to. Oh, okay. So it wasn't that. Hang on. I kind of I don't know how to make the bell settings more memorable. Maybe if it wasn't just like this yes and no. Use standard library. So I have to go like this. So this is the way. Like everyone asked me, what's the setting? You know, and I was like, yeah, let's go. let's go to the source file and kind of do this, which is the fastest one. Maybe I should just have this have one for the one terminal window with all the settings. So when people ask me, oh, it is use.stdlib. Didn't I type that one? So let's see. Use.stdlib. No. Oh, I added between the output. Okay. Now let's see. Now we don't have that. So here's maybe not. That's there here, right? And it's going to be. So we can go in here, right? So we have. This time it's not a parameterized one, right? So let's see here. So we're going to get the error here, which is nice. And then we have the second error, which is this one, which isn't nice. That one isn't nice. Okay, so we're going to grab that in imports. And we're going to grab that one with true, which means we want the generic version of it. That means same module can have both of them, which is like mind-blowing bad. It shouldn't have like one generic version of something and one non-generic version. See, this is why I just like to do some exploratory coding like this, because then like the problems kind of resolve themselves. So what we could do. Well, we could do like this. So we didn't find it, right? And then you kind of try to find it in the generic global symbols, I think. Right? And that's when it fails. Or no? If we didn't find it in the global symbols, so we're not in generic symbols. All right. What the heck does that mean? Oh yeah, so now I get like it's not there. There is no error because this one can cause, this one here can result in an error when something happens. Like if you can't resolve an ambiguity, then that's an error. And oh, wait. Is this doing the right thing? I don't know if this is doing the right thing. Like find decals in. So this is going to be silent, yes. And maybe there's no hit at all. But these are supposed to report that. This is weird. Is it because it's just going to be like a false if there is no reporting? Let's see. Let's not, can't resolve the ambiguity. And first is preferred. I just, oh, we're gonna have, okay, there is an analysis. So you can get actually the error. Right, okay, so there is an actual error there. Okay, so now we're gonna go here and we can't find it. And we can't we have some ambiguity, I guess. Right? But we can just step past that because what we want to do, like once we're done here, and we kind of we're not, do we print an error? No, we didn't print an error, so we resolved that one, so we didn't find it, right? Hang on, where are we? Let's just do this one, otherwise I'm confusing myself here. So let's find the declarer in the imports. And what happens now is that we don't have a match, right? We haven't found it. We do this and then we just continue. We are in here. And now we want to report an error on this one. And we don't know. Let's see here. So and oh yes, good an error. So because it couldn't be found. So then we need an ambiguous. No, it's not ambiguous. We get so the maybe name. If name resolve, maybe decal unit module. It's not in a generic module. And something with name resolve. Maybe it's like, do we have something good here? We want to know that, maybe we want to know that try to resolve in a generic setting after all. So in this case, we're going to report on Decal pool was parameterized. Just enter something there because I want to edit this. So make sure. Okay, so in the case it's a common, it's a false. But if it's a parameterized, it's a true. Okay, so now we go in here. We know now. So maybe Decal else if was parameterized and not was parameterized. If so, like this, I guess. If not, I hate when it gets like this iffy with nesting. If was parameterized, then we're gonna get something similar. Did you mean in the module? Blah blah blah. If so, don't use generic parameters. Okay. Now, if I run this, nothing is going to happen because we didn't actually check that. So it's going to be not going to be doing anything, right? It's just going to be if foo cannot be found. So the next thing what we want to do is like we want to find this Decal in a like is it there at all in a non, if we can find this like okay, so if name found, so if it's found, or name resolve, maybe Decal or name resolve private Decal. In this case, if it's not, and not this. Now in this case, try to find it in the global, where do we use that? So it's the normal context like this. Right? And we have that false. Now if we have name resolve found, in this case and only in this case, we're gonna set name maybe Decal to name resolve found, and this we're gonna set like a name resolve private Decal is gonna be like null, because we're not going to handle that case. And name resolve maybe Decal is going to be null anyway. And this here. So okay, if we're going to suppress the errors, we're not going to do this at all. Otherwise, we try to go for this. Okay, let's see what happens. Oh, we got an error. Woohoo! Let's see where we got that one. So here it should be a Decal path. So let's think about this. When does this happen? Okay, we're just going to say like, okay, it's a parameter count. If parameter count is 0, then we just do this puts to do, and then put a breakpoint on that. Let's see, this is just like, this is hacking right now. Okay, we're going to resolve the generic type, blah, blah. So, right, we're going to go for that, right? This is what we did. We're going to go for this. And that's what we did. We're just going to go in here. Let's see, let's follow that. And now we maybe have that. So we have a maybe Decal. I forgot to set name resolve to found to null. Right. That should do it. Right. Oh, we got a worse. Oh, it's going to be like looking at the generic module and stuff like that. That's not what we want. So we just need this. And we have to remember to remove the puts there. Did you mean struct foo in module test? So don't use generic parameters. This kind of looks like we did what we wanted to do, but I don't like it so much. Let's remove this one. Right. Let's see how many tests break with this. Oh, we got something breaking. So analyze identifier. We get here again. Right, now we are resolving some generic name, which is so we have a list, right? And then we managed to find that one in something. Okay. How? How is my question? So the thing you can do here is like if parameter count is equals 0, then let's run this again. It should be fine to run. So now I can see why this happens. what the code does that's wrong. What? Oh, I was assuming we had a decal path. We don't. We don't. Let's move this back to start 0. No, I don't think. Now it's not breaking, I think. Yeah, now it's all passing. Maybe I should stop for a little while and have a look at pull requests instead. To look at some code, some C3 code. I guess let's see if this works. So should one or two of those test cases, I think, should break because here it is. Here's one. This one, module generic mixing. It doesn't fail anymore. What should be it ought to fail, basically. So what you can do now with this, right? What's the point of allowing this? The main point is that if you have something like list, right? So you have this module collection. Let's extend that one. Collections, right? List. Just let me look at that. So it's not saying anything weird here. So we have the list, right? And it's a type, right? So what can we do? We can do like macro new and of a type type, and then we can return a list of that type, right? Now this allows us to do additional errors there. But basically, if we wanted to use that, we could use, like before it was, if it's in, like, let me put it in list, another one, right? So it's inside of the generic list. New 1, new 2. Like, of course you wouldn't do this, but just bear with me. So if you wanted to have something like int list, right? So we define int list, which is a list of int, and then you could do, right, with this one new one, you could just do list a new 1 int. That would be an int list, right? And but before, you would have to do like this, which is in u2 here, you first need to have an int, and then you have, an int. Of course, you would never write that, but in some cases, this kind of you want to have it parameterized differently. Right. It does. Well, it has some advantage. It's also bad. Oh, I didn't even type this right. It's also bad because of this. Okay, let's throw that away. Just let's keep the fix. So what is the fix? And what do we throw away? So here we don't want this anymore, right? We don't care about these anymore, right? Let's remove those. And then this is the place where we're actually doing checking. So we're gonna keep that. And then here we're gonna revert that. Don't be afraid that I'm like throwing these away. It's quite healthy to just not do anything, not do everything that strikes your fancy. But it's like this is the way you kind of get a feel for whether it's worth it or not. So let's go into the context there. So where the actual fix was. So we're gonna create that, and we already had it, and now this is it, right? So now this case we don't have the old code. Like the old code would create different things, but now we get like a module. If it has, so we have the old code, the old phrasing, which was like something like this, and this is still true. So we're gonna keep this. So we're gonna keep this if the parameters does not match the generic. So maybe we want to handle, we're done, right? So we can just gonna get it done. Let's jump. Okay, so if these are the same, if we don't have any parameters, if the module is not generic, if it's not generic, so if there are no parameters, then go to done. Run, right? We are fine. But if there are any parameters, then we just going to say like, okay, this is bad, right? And then now we know that we have a generic module. So if there are, oh wait, so yeah, we're gonna keep that one. So okay, if this, sorry, if this is, if module is generic equals doesn't equals this is not null, then we are in an error. That's very bad, right? Then we have the case where the module is not generic, then we go to done. Then we have the case where the parameters doesn't match, right? And then we have the case where the type inside might not match. And then we go to done. And then we do this, but we did this like the main flow, then I don't know. Okay, so something like this. All right, now let's go back to this original example, right? And test that it properly errors. So if I do like this, do I get a proper error? Well, one less viewer. You got upset that I was destroying the code, right? Okay, the parameters of the generic module test2 doesn't match. Parameter. Yeah, it has to be parameters, right? Because you can't have 0 parameters. Parameter declaration, maybe. Let's rephrase that. So the parameter declaration. parameter declarations. So let's can be found here, maybe. Generic, okay, generic, what's that? Generic, the generic parameter. No, so generic, okay. Let's get the last update here. Parameter declarations of the generic module 2 doesn't match. Don't match. Don't match. Don't match. Can be found here. Okay, I guess this is good enough. So then what we always do, is that we want to add a test case, so that never again can we be bitten by this thing without noticing that. So we have some folders. There are a lot of folders now on this side. So let's see, we have generic, so let's call that different generic def C3, and then we can add that one, pull this thing here, and then we always do like this. So we're expecting we're gonna get like an error message on the second one. So here, this is how it looks like if you want to add one of these tests here. This is the way you show that this is going to be a parse error, or some semantic error here at this point. So just if you write this and you have like testing parse errors, you have to know that the semantic checking will not happen, and maybe parse errors might stop things. So usually parse errors you just test one, and semantic errors you can test multiple ones. And this is a parse error actually, because this is like it's getting registered very early. So I think this is a parse error. So anyway, so I just write like this, because otherwise I can't know that I'm actually fixing this bug. So this is how I do it. So now I have to wait, because this is like, it's not super fast to actually go through and create LVM IR for everything. So you see it's like taking half a second for everything, and so there are a lot of them, and that means it takes a while. Like the worst thing is when you change some lowering, so some fundamental lowering, and you have to add update 1,000 of these. No, not 1,000, because there's just 900, but like hundreds of them. One by one, you kind of copy pasting and diffing the output. That's fun. Okay, so if we're lucky, we get it soon. Like we get it in an early test. But I don't remember. Like we're in ABI now. There are a lot of these for the ABI. These are actually stolen from Clang test cases. So a lot of them, like the ABI ones, the really gnarly, you don't know like what you're supposed to do. I grabbed them from Clang. So happily, those are helping us, stay close to what Clang outputs, at least for the ABI. The ABI being the when you call a function, you have to pass structs in a certain way, because the computer, or I mean the computer only has the registers in the stack. So how do you put something arbitrarily big, a structure something? How do you put that on the stack? Well, you have to put it in registers, maybe, or put in the stack, and the rules on how you do that, because you both have to know how to put there and how to grab it from there, and that's the ABI. And it used to be super simple in C, where you just took those arguments and just put them on the stack. So you just put them like one after the other, copy them to the stack, and then oh, something. Oh yeah, that's the one we wanted. That's the one we wanted. Okay, so you just put it on the stack, but now with modern CPUs, there are so many registers, so the API is like, yeah, put it in the register here, and then you put it, and then you think of this as, oh, a declaration. So it's not a declaration. If you're watching, you have to help me with this. Declaration, right? So like that. Okay. You're supposed to pick up. Can we get like an AI here, kind of can catch my to watch and kind of notify me when I make typos? Okay, release notes. Now I have to add this fix. So we're already on 0.6.7. It feels like spring. Let's copy. I'm going to copy this from the report. So compiler allows two generic modules. Now the generic module to be declared with different parameters. That's what it actually is. I'm just gonna type that. Sorry, I just that's why I think it is. And now we should do that, and we should run the tests again. Okay, so anyone having a question? I'm just going to look at like is the Discord something? Like if you have something, what should it be? Okay, so I was just like asked what it should be if we had that, but oh, do I come and go, or is the connection okay? I have my kids like playing now. Oh, okay. So let's see. Idea must have some nut. Yeah, it has. It usually has. So I don't know why. Do I break up a lot for you, or is it fine now? Because my kids, I mean, I noticed that my connection has been like very odd recently. Just breaking up sometimes. Yeah. So there is a language checker, but I don't know. Maybe I because of this dark text here, I was noticing it. Or maybe it just thinks that this is a new word. I don't know. Anyway, usually type checks for me, but not this time. So let's see. It's 11:22. Okay, let's do a little more. Just going to put this in master. Meanwhile, we can look at the pull requests. So we have several of these actually, and I should have. I feel a little bad not having worked on these, but I had really a lot of stuff to do the last few days. So okay, so it looks like the tests are passing. There are 200 more to go. I was going to look at the Golang like channel. There has been a lot of discussions in that pull request, and I haven't looked at it at all because once I look at it, I have to really look at what's happening. So now we're almost done. Let's run the tests till the very end. And maybe I should just, I don't know if anyone anyone who is interested in this is online. But let's see here. So So yeah, maybe. So I think let me just have a look at this. So there we go. Let's push that. So push. The power of being the maintainer to push things without having to go through these pull requests that are like, I've done a bunch of those, so I know how it's like praying. Like I did all this work, can I actually get it into the into the compiler? So I'm gonna check it. This is very fun because when I do this on CLion, it doesn't like you pick checkout and you have to do it twice. Otherwise, you actually don't get it because the first thing is like a no op or something. So let's see what happens. So here's the changes. I don't see what the changes are for thread. Oh, it's the channel closed. Channel closed. That the one I asked for. Otherwise, it's all new stuff, right? So, and we have a test here. So there is some test on how this works. So this channel. Let me just go into the code. Let's see if we can figure it out. So Chan. Okay, so there's a Chan, which is an interface. I'm going to make this into standard. Like I actually like Alman. I'm gonna like, for me that's clear, even though it's taking more space. I'm not a like say that one is like necessarily better than the other. I don't care about tabs at all, but I do care about consistency. So that there has to be consistency. And let's see here. So you're getting, this is like defining a new buffer chan. I don't know why it's not called a channel, because chan is just unnecessary. Okay, but let's go with that. I'm just not complaining, just saying that things like that I'm thinking of right now. And oh, I'm in review mode now. Can I turn it off? I don't want to remove this review mode, please. Oh, okay, and then I got some weird stuff there. Okay, so it's actually not used to having this parameterized interfaces. I was never thinking I would actually see this. So I don't think it's a good idea, to be honest, because it just the way it works is that you'll like create a lot of these interfaces, and the point with an interface is not real. It's like it's not supposed to be like an interface in the sense that that the Java interface or something, that you're like, oh, I'm going to have this like they do here, like the buffer interface. So there are two of them, right? The unbuffered channel. Damn, I get this. I have to close this. Maybe it will allow me to look at this in the normal way now. Can I turn this off? Disable review mode. Thank you. So I'm not going to look at everyone else's opinions on this. So I'm buffered chan, right? And so I don't blame people for making this kind of design. I'm just saying that let's think C, right? Let's think that we're doing something for C. So while this like it's inevitable that we have to do. Sorry, I'm just doing this as we go along because we just put this on a single line because that a single line kind of guard clause thing. I think of this like an assert. That's the way I do it, and that's just my style. I don't want to necessarily require everyone else to do that style, but that's just the way it works in the end. Like try to keep it like that. I'll get another one. So let's see what happens. So we have a channel. The channel is going to, that's like a generic thing that you're going to implement and that's going to return a type. So you're going to go here, you're going to get this by value. Yeah, fair enough. Do we have to do, are we going to have a lot of channels? Are we going to have a lot of channels? I see like one entire channel. Is this channel thing used anywhere? Do we need this? Why do we have this? So is anyone online? So let me maybe someone here. So here. So let me. Oh, we can't see the diff. Oh, only two. Okay, there are. This is like the buffer now, the unbuffered. Yeah, I see that. But do we actually want to make, do we need an interface? Do we want to access this using the interface? Or does it matter to us, can we maybe hide this thing behind something else? How do we envision that we are using this channel? So I could maybe look at what the tests are like. So we have some tests for this. So channel, there we go. The tests are here. So okay, so we have a test here and it's going to create a buffer channel, right? And we defer it and then we destroy it. We're going to create a bunch of them and we're going to create the channels and destroy them. And then we're going to push something. And then here we're going to pop in the same thread, right? Okay. And now we are somewhere and then we push things and then we pop it from the other thread, right? That's the way it looks like here. Okay, and then we have the other one where we create another channel here and then we push it and we might get this thing. Now my question is here would be, do we need to have generic? Do we need to have two things that implement the same interface because they want to share some functionality where you put in just the channel and you'd have no idea what the channel is? So that's like in Java you would do it with an interface because like there is no cost. There is no cost at all to do that, and you don't pay any overhead because you always access things directly. So on that object. And sorry, I'm just doing this like a. Oh wait, why is this assert false in here? If there's an error, why don't we just throw this better? Just saw this. Because we can assert false anyway. Let's see what error did we get, right? So okay, like that. And in this case, we're gonna throw, right? So there we go. And here again, so let's throw. We fail the pop. Panic. think I've gone through all the different cases here, right? Okay, let's see what you're saying. Okay, so a search file is like enrichment. Yes. So the channel will also be used by pointer. I use the channel interface to hide the implementation, but yeah, you can do that, but when okay, let me show you an example, right? So in the case of the standard library with IO, right? So they all implement the stream protocol, but that's like, why do we do that? Well, it's because there are then methods that will take the stream. So you have I can just get a file. Let me see if I can remember this correctly. So we're gonna get a file, open. We're gonna do it for write. So we're gonna call it foo text, and we're gonna have it for writing, right? And then we're gonna have, we can have another stream, which is this stood out, right? Is it like that, or do I do it's like this, right? The IO stood out. We didn't even notice that. So on this, I can do like fprint n of this, and then something foo, right? And then I can do, take the fprint n and then do the same thing, because both are they're going to take like this, going to work on both of them. Let me see that. Maybe I misremember something from the standard library or something, but something like this. Okay. Whoa, boom. There we go. Right. Stream. Did I? Oh, why isn't called that? Didn't I grab everything? Or did I? Okay. Let me just throw that stream. Now the stream is there. Isn't called stream. Yeah. No. Sorry. Outstream. Outstream. Right. Outstream. Did I get that by this? I didn't do that. Right. Now finally, sorry about this. So okay, then I should have used like listen to whether this actually has an error or not. But let's suppress that. Okay, so we're gonna put this foo to both of them, and now one is standard out, and also we get like this file somewhere, which is foo in there, and we can have a look at that, but it's gonna say foo. So we have foo somewhere in my test fragments here. Let's see if we can find the foo. Where are you, foo? It's actually in alphabetical order, so it should be. Oh, hang on. It's there. There we go. Yeah, so it's there, right? So because we have like methods, functions that can work on the same thing, right? We want these kind of functions. So the question is like, is that what we want to do, right? So is that why we have a channel or not? But what makes me kind of wonder whether we do that or not is the fact that we have the type. It's going to be like one of these for every type we have. But maybe, I don't know. That's the one. Let me see what you write about this. Okay, so that basically will be used by pointer, not by value. Well, if you want to ensure that, there's a much simpler way. So the way you do that instead is that you are going to, you're going to create a, it's going to create like this. You can do, oh, is this in the, this is the, yeah. So I can just do this. So this is a distinct channel, and it's just going to be a void. Okay, and now let's say we are, of course in this case we can't use the interface, but we can use the we can still make our own vtable to call different things. But this is the way, kind of the way, if you just want to hide the implementation. That's why you would get around that, and you can basically do, like, you can add function. So I can add a function for the channel, right? And it would just take channel by, like, let's say we're just gonna init, right? So is this real? This is the tests. I was feeling that this was not the right one. So okay, so we have the buffer channel, right? So what you do is you basically do like this. So then when the int goes, we have a self, and then it can look like if we can just have some prelude to this, which is the same. Like the buffer and the unbuffered has some prelude, so that you can just look at this self and then cast it to some inline part. So we have like we can actually do, let's say channel is not a bool, that would be crazy. Well, it could be a bool, and then this is an inline bool channel. Oh, channel, right? So like that. So in this case, we can just say, okay, if self, right? If that, and then we can assume that this is a buffer channel, and then we do buffer channel these things here, and otherwise, else, we do unbuffered. So let me look at the so this is the way I mean this is the way some things work, and it's a nicer, it's a more direct thing. Let me look at your buffered and unbuffered solutions here. So the unbuffered one has some mutex, unconditioned variables, so read waiting, and the buffer channel similarly has something in common, but not everything. And of course it has the buffer itself, which is inline. And then when you init this, you will do that. You also always create that one, right? You have a create somewhere. Let's see here. So I'm not blaming you for making this assumption that it should look like this. It's just saying that there might be a different solution here. So I'm sorry for doing this, but just and you might wonder why I don't do it here, but it seems like a lot of things is happening. Maybe you want to have a breakpoint there or something. Okay, so you get the errors. This, I mean, the code is fine, but it's just we might want to do it differently. So it's worth thinking about. Sorry, my English is breaking up. Okay, so so this is like this is what I'm thinking about here. This is my concern, that maybe these should be like one thing, and then you just have a switch. Or you have a common part, and then that common part is what you what shares this data. So let me show you what I mean. Instead of being like, let me pull out this one. So I think that these were these the same? The buffer one? No, it just says these are the same. So the send cont and the read waiting, those are the same. So we could do like this. We can have like a struct base channel, and that one is like just continues. It contains these, and we have a bool somewhere. Let's put it here. Is buffered. Okay, and then our buffer channel, and we don't need this anymore, so I remove that one, and then we call this then we inline the base channel, right? So it's that, and then we can remove this part and that part, right? So we're gonna get this. Some of these are going to be the same, some are not. So we're gonna get the common part, which is the channel, base channel. So it's gonna be like we're gonna implement the base channel into here. So base channel destroy. I'm just showing. I'm not like saying that this should be in. It's just showing a possibility. And it's important that you understand that I'm not saying that. I mean, this shouldn't necessarily be like this. So okay, so this is what it can handle on its own, right? But if you are in a buffer channel, so if you are buffered, so like this, if self is buffered, is that buffered? Yes. In that case, we're going to cast this to a buffer channel. So I'm just showing some tricks. So now I cast that, and now, of course, I have this already, right? So I can just put this up here. So now it starts with 0, right? And we're going to do the same trick that we did for here. So we're going to get that one. In this case, we can just put the value in there. So if it's a buffer channel, what we do is that we're going to do destroy. Did I destroy this one? And I mess it up. Okay, so then we can look at the unbuffered channel. How does that shut down? So how does that destroy itself? So it has also, wait, hang on. Does it also have a mutex? Oh, it has, okay, so it has a mutex. Then I should have actually put that into the common thing, right? So it's easier if I pull this into the same file here. Okay, so right, the buffer channel is that, and the unbuffered is this. Now we're gonna have a base channel on top. Base channel, and it's gonna be inline. And we have a mutex, and we're gonna move that one into the base channel there. So now we can remove that from this as well. Okay, so, and this goes away because we already did that, and send waiting, that's also gone. So this is what we end up with in the unbuffered channel. This in the that channel. So we have the send x and send read x elms. Okay, so now we have that. Again, so we can, when we destroy, we either destroy, so we have the destroying the unbuffered. I know this isn't very sexy, but I would actually do it like this. So let's see. So this is the or at least I would consider this design. And maybe I decide that okay, this is not good, and then I'll remove it. But so okay, we already have this. There's no need to do that first. Okay, so we already did that. Let's see what we do different. So if it's not buffered, then we have these extra. So we can add. Okay, I'll guess I'll have to add this in here before doing the send, and then we need another one before we do the read. Right? So okay, now we've just done it in exactly the same order. Okay. Now that covers the destroy. Now we can look at just the push, right? So what happens when we push in the buffered and unbuffered cases? So again, it's possible to just, I mean, it's an if statement. It's not as efficient as, well, it's going to be faster actually than going through the interface anyway. But okay, let's do the push. I'm just trying to find where I put the base channel destroy. So the base channel destroy is there. So let's put the let's imagine that we just put these together. So we have the push here for the this buffer here. Now everything turned into a single one. So this is the copy. So this is the second one, and let's put something around it or something so that I see that they are different. Right, and it's going to be the base buffer. So they are both going to lock and then unlock, right? That's the both of them are doing that. And then in the case where it's an if it's a buffered one, is buffered, then we need to cast it to a buffered one. So buffered chan is buffered chan. I'm doing this just to like get a feeling for how it will look like, because there is not that super super big amount of code in here, right? So maybe so maybe this okay, I'll do that later. So okay, so if this full, then we have like this is the buffered behavior, right? So this should all these no need to use the chan here, right? So because now I suddenly add this thing, right? Okay, so we can't wait. That's the normal one. So right, it's in self. No need to forward that. Okay, so we have this. Maybe they share close to. I didn't check that. So you had something like this, right? And sorry, right? And then we move the pointer. So maybe you can do like this. No, let's look lazy. Okay, let's not do that. If it reaches size, then we go to that. We go to 0. And then we're gonna increase the elements pointer, that's going to be channels again. And then with a read whiting, and then we're going to have this signal it, right? And then I'm not sure what now I'm at the other piece of code, I think. Yes, so this is that part. And we can just return. And in the other case, then we're just going to do the same thing, but the unbuffered. So we just have this push and pop, right? So, and then we're going to do the chan. So, like this. Yeah, they are shared, the same closed. That should be moved as well. This. Yeah, you get the point. Let's just, okay, I now do very sloppily. And because I see this one at the end, I understand that, okay, you want to have an error there, but I would not do that. I would just ignore that. It would have to break and lock on the lock. I don't see this happening in a normal way that makes sense. So it will look like this, right? So this would be the entire push, and then we have like, then it's just like one behavior if you have the buffer, and the other behavior if you don't have it, and it would all be called by this base, the base buffer, but then the base buffer itself can be hidden. Base channel. But then this one can be hidden, so it can look like this. So we instead have a macro, which is a channel, which takes this and takes itself, and then do a push. And then this one will cast itself to a base channel pointer, and then call push on itself, with the value, of course, like this. We can even put that one in a single line if we want to. I don't know if it's useful, but our channel is going to look like this then. So the channel itself works as a forwarder. So we have like, we're going to have like, okay, pop, which is going to take like a type, return a type, presumably. And this is going to, like, all we're going to have. Maybe we have this destroy as well. Right. Like this. And there is no way to know what's behind it, because it's just going to be, the implementation is hidden. And you always get it by a pointer, so that the mutex is fine. So that is a way to do this, basically. Like, looking at this, there's not super much code, and I think it would kind of, if we only have this, like the buffer channel and the unbuffered channel, then definitely go for this kind of more closed single thing that does everything. Is my thinking. You could even, do the dispatch, of course, with the buffer channel. So now I just put everything in here in this kind of this big thing here. But you could also always do, like, if you don't have this, then you could do like, okay, if self is buffered, then let's call, return buffered chan, and then self push file, and then you have those separate. But I think, like, actually I would actually even think, consider this style. So I would consider this push buffered chan, right? Buffered chan, chan type file, and then just do this code here, because there is not, I mean, at the end you can do this, like at the very end of everything you can do this push, this like method style, but keep it to a function until that's needed. That also like avoids thinking too much of this like self. It's hard to reason about this code. Actually, it's not as nice as if you have a function, because it's like very more clear what you're doing. Okay, let me look at in the comments there. Wait. Okay, so I think now it's more like a mess, right? So similar code goes in mix one. So on the thread, mutics are made the same way, and the can't yet. So you can refactor out this and have this. This switch here is going to be like super fast anyway, and this one can be inlined, right? So you don't need, like, it's a matter of like sometimes you for the stream, right? The idea here is that you can, if you go back to that example, right? So we have the stream. The idea is that I can make another stream that doesn't like that. I'm going to expand this with like any type of stream, and the streams are going to like go into each other, and it's going to be like very loosely coupled, because it has to be. For example, printing has to be very loosely coupled, because otherwise you would have to recompile a formatter every time, and the formatter would need to kind of import all the types in order to know like how to print all the types. It would be a mess. So what it solves, this stream, so this interface solves, is like this necessary and loose coupling. But if you're just doing 2 channels, right? Maybe 3 channel types, then we don't need this. Like, are people going to code against the channel and going to get different channels? I don't think so. I think you just want maybe an unbuffered and then a buffered one, and then maybe some other variant of this, and you're going to be like fine with using these just very tight code, very simple code, but very functional, and it kind of works. So you don't need the fancy, there's like a these method kind of things that you see, where you have objects flying around, which have different capabilities, and you kind of apply them, and then maybe they support this interface. That's not real C, right? That's more like Java, even Rust or Go, but it's not C. Like C, you have file. This is the object-oriented thing. You have file. It's already actually object-oriented, but because you can have files of different things, right? But I needed another abstraction, so I have to have the output stream, this output stream and input stream. But otherwise, like this is the file is that's it's a pipe pointer, and there is some data in there, and the file methods kind of go in there and find that data, and you don't know what's in there. That's the abstraction, right? And you do that because you want to expand with different file types. You want to implement a lot of them. But the channels, consider that. Consider whether the channels are um, are they open or closed? Is it like an open set? Do we, define now? We define what type, what kind of, what the interface of all channels should be. Is that what we're doing? Or maybe it's just like maybe the channel is just a list, right? A kind of list, and we have two kind of. I mean, I'm not making a like oh here's a generic list, right? We don't have a generic list in a list interface in C3. There's just like there are different lists and they take you're able to do things to them and you can test that, but we don't have to kind of have them hot swappable. You can, because of macros, you can kind of put things and you get a generic thing going. But the code can already know. I mean, it can optimize. Okay, this is a list. This is an array. It can adapt the code to that. It doesn't have an interface that it conforms to. Actually, we could make an interface for interrace if you wanted, or in slices. That would be totally crazy, but it would be possible. It is not possible to kind of declare it as it is, but you can create an interface, and then you can declare this dynamic methods on the integer types and so on, and could actually work with that. But don't do that. But it's just possible. But I don't do that. The it's you have to get out of this object oriented mindset that is really easy to slip into when you have methods. And I think like the push method here, that one is like push and pop. That's okay because that's basically just mutating the inner data of this thing, right? So it's just mutating that in a safe way. That's totally fine, right? And so in general, the methods here on the channel, those are perfectly fine. There are a lot of cases when they aren't. But so the push and pop, I don't mind them at all. Those are fine. But I don't think we need the interface basically. So I would kind of take the interface, throw that one away. The interface looks really nice and stuff like that, but don't let that fool you into using them necessarily. We don't need. This is not a place where you would need to have virtual dispatch or anything like that. Now, actually the interface doesn't actually have the vtables and quite like that. It's a bit different, but it's the same thing. Like do you want this loose behavior or not? So sorry, I'm like going on a long rant here, but and also not really a rant. Nothing against this. It's just I would sit back and think, look, when I use the channel, is it important for me when I use this object to know whether this channel is blocking or not? And I would say if I am using something like a channel and pass stuff between threads, I would need to know if it's not blocking or not. That's like an essential need for me to. I mean, I must know that it's blocking or not blocking. If it can be either, yeah, I don't think. I think I would like. I mean, let's scrap my idea. Let's scrap the thing that I just show you with everything sharing, right? So that's not what I want. So what I want really is, can we just jump back in time? Let's do local history here. I could just throw away my stuff. It doesn't matter. So what I want is essentially, maybe we can go like Can I go back in time when everything was better? So yeah, let's revert this. Okay, so essentially I would just ditch this part, right? This is what you need to ditch. So so just in this case, like it's a buffer channel, it has a size. I know you looked at the ring buffer. I don't know if this is good. Because what you can do instead, like this is what you can do instead. So instead of doing that, we can do like this, right? So, and then we put this as a, this is much nicer. So what you do is like this. And now, let me see, if is there anything, if you are, you know, you want to be allocating this, right? So let's see what the examples are. So wait, you're putting this on the heap, on the stack. Because if you're not putting it on the stack, you can have like you can do like this, right? You have a variable size buffer, and then you allocate. You can have like, okay, so you basically want to create a buffer chan, and then you have like create, I don't know, new and have the allocator, and then we have like the size, right? So we can have size, and then you can allocate, so allocator, and then we can have, there's a method for this, let me have that. So we have mem allocator, and then there's a nice thing here, so you get like a new with some extras, right? Let's see if we have the one, a new allocator. So it's 1 or 2 arguments. New with padding, that's the one I was looking for. So new with padding. So we want a new of those. This is exactly for this usage. So then we could have like, okay, new with padding, and then we want a the allocator, and then we have the buffer chan, and then we have like the size. It's going to be like the padding is the size of type size of, or maybe just type, yeah, type size of times the size, right? So like this, and then we have it, right? We have it there. Okay, and then we resize it, and we just have it's going to be like on the heap now for sure. And you can like complain about that, but it's on the heap, right? And since you have like this on the, you know, a pointer to it, anyone pasting this and then deref it and then, you know, try to copy it is stupid. So they shouldn't do that. And if they do that, then they you know, you can ignore it. So if since you do new, you can do the init as well, right? So if you have that, you can skip the init, and then you just like, you know, you have the buffer, you have the like the buffer chan, and we call that, to be very lazy, we call that self. And now suddenly I can do all of this. Let me just move it in here. Now we're done. So we have the new function. Then we can, you know, make some. So we can make. Let's make that one. So like this new. Let's call it create. Right? So we call it create because that it does have its allocator, right? So it requires the allocator. Then we can have like convenience methods like new, which just takes the size. And that one is just going to call create, and it's going to take the heap allocator and then the size, and then we have the temp. I don't know if that's very useful, but it's going to be like this, right? So now I have like I created those, and then we have like the story. Okay, that one we just keep. and then they push everything that is just kept, right, as is. And there's one more thing. There's like close, right, and there's destroy. And the question is like, okay, so what's the difference? Like, do you always, do you close it and then destroy it, or destroy it and then, shouldn't they be doing the same thing? So I think like maybe you could consider putting them together. May just make it destroy. And if this like fails, maybe create is bad. It's like maybe it should be like open, right? Open. If it's like close, right? So maybe close could be removed, or close is destroy, and then you have open, and then you have temp open, and then you have new open, right? And then we're done. Something like that, right? And then we always allocate on the heap, but always is a strong word, because if you have use this one, you can use the on stack allocator. You can create small allocator that's just some memory on the stack that we can wrap things in an allocator. You can get a temp allocator. So if you have just want to on the stack, maybe you just grab it on the temp allocator instead. So those are my suggestions here, watching this code. Removing to summarize, like remove the interface would be something I do, and then I would actually make these different, have some guts and make them, these are the ones you're going to use, so they're going to be like big, important, and call them something buffered blah 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 channel. So maybe it's like buffered channel is a bit, and maybe it's enough, unbuffered channel, buffer channel, yeah. But I wouldn't definitely want to know that I'm using a buffer channel, because that changes my use cases. So okay, so maybe because this is like a buffer channel, you can like do like this, okay, this too. So you can like have, okay, this is kind of question. So this is a possibility. So you can just call it channel, right? And in that case, this would be like channel new open. So then you would have to change the names, like open buffered, right? Open buffered, and that would be create buffered, right? Because then usage would be like channel create buffered int, right? Like this. And then you would have a new open, and you have a corresponding unbuffered channel new open unbuffered. Of course, you could, just unbuffered. You could, of course, just have like a Boolean, but I think like you're not going to switch between them. Oh, let's get a buffer this day, and now I want an unbuffered, because it's going to, all those considerations, because as soon as you go unbuffered, you're gonna have these blocks, and you want the blocking. And once you have the buffer, it's going to be like quite different thing. And okay, unbuffered. Sorry, I'm just getting a bit tired here. You don't need the size anymore, right? So these are some ideas how to take this. Okay, so what if we use a union instead of a base channel? Yeah, you can do that. But I mean, like I showed, yeah, I mean, definitely you can do that, but then it's just going to be as big. Both are going to be equally big. That's like the thing, because one is like the unbuffered one is going to be size dependent, right? The buffered one, sorry, the unbuffered one is going to be fixed size. So that's why you might not want to union. And not need to destroy them freed. So I think like if you're not going to use stuff to close it, then you can just as well like have one operation which is destroy, and then it's like everything is taken care of. So any other questions? Otherwise, I'm just going to. I feel starting to feel a bit tired, and I should probably close the computer now after staring at this dark screen, which I'm not used to. I hope that this was a little educating, even though I didn't. I don't want to. Like when I use this, like as you see, I've now shown several designs, right? This design, which is getting things by pointer. I showed a design where you kind of go share things, and these are highly dependent on how you think like the user is going to approach this, and also you need to take it for a spin, right? So if we're talking about back in, where's the test, right? So this is like the let's look at the one of these tests. So this is the push pop unbuffered with locks. So how would this look if I used the proposed thing? It would be like something like this. So I'd just go for like this channel, right? So we have something like this, maybe channel temp. Oh, we're gonna have a new unbuffered, right? So we're gonna get that one. So now we have a it's going to throw. So we're gonna try that. And now we're gonna defer destroy, right? Yeah, it's the same, right? So, and now instead of this one, this is not good. We're getting a pointer. This is not really what you want. Okay, but that's another thing. That's a different thing. So, okay, so unbuffered channel. We know this is just this pointer, right? So it's that. So and then we have the same interface, and we got the pop, and then we got pop, and everything is the same, right? So what we change is basically this one here. So we don't change much from this thing, and for the buffered channel, it would look like buffered channel. The way I was envisioning it, so you get that and get a pointer to it, and you would get like a channel, like new buffered, or open, new buffered. Okay, we're gonna go for that. New buffered, because we have buffered and unbuffered, then we can skip the open probably. So then we're going to get like that int, and then we have the size, which is 1 then, right? So yeah, and then it's going to throw. So like this. So for going from, this is certainly smaller, right? But mostly it's because of this thing here. It's a bit long. So what happens if it's about the same size? So it's like this. So actually they are the same size, these two. So you got that. I would probably do like this. So I would define in channel is a buffered channel int, right? So instead, like if you do this once, you will thank yourself. So now it looks much nicer. So because it's more verbose, so less different things. So you get an in channel, which is kind of communicating what I want. It will look like this, right? So then we have these competing with each other. So I think I like this better. I think I definitely like this. It's just kind of, it feels natural that I get like, oh, that's a new buffered, and then I get like the size. I can probably get like the right size, maybe like this, right? Maybe you should have some default or something too. Yep. Okay, that's all. And okay, one thing that could be done to prevent the referencing our channel is to do something like goes down with the map, make it a distinct void. Yeah. So I show that trick right before that. What's the sound? Sorry. No questions for now. Do you also need init? No, the init was inside of new, so you always do that. Okay. Right. So otherwise everything is fine. Just I was just changing the Alma braces, the braces to Alma style. Yeah, and then have a look at what you want. But I think you should skip the interface. Let's keep the interfaces few. When you really need an interface, they are great, right? But if you don't need them, don't use them, because they kind of it's a code smell basically to use that term in C3. So it's once you do that, it's you might be thinking in a more general terms than you need to be doing. So and you know, one more thing is that, let's say someone comes up with like, oh, I really need a channel, right? I need a channel interface, right? So they write this channel, right? So they want this interface. Maybe it has to be like this type, but let's look at this. Like maybe they need to have this, right? So they need to have this kind of thing. Oh, sorry, that was not. So it's void push int pop. It should be type. This should be general, but let's say you have that. Then, if you want to, you can define. Let's say I want to add file as a channel. So I can actually do this. So I can actually do say that, okay, let's make that a dynamic method, right? And it should be returning, sorry, it should be returning, what is it, push should return this, right? And then now this doesn't give you like any safety at all, but I can do like this, and I pop and I return 1, right? Okay, so what I can do now is actually, and I have to have that dynamic, is that, oh, maybe I need to revert all these changes I did first. Sorry, let's see here. So these are the changes I did. Let me revert those completely. So in this case, I can actually, let's say I pretend that f is a channel, right? And then I want to print what I pop. So let's pop. All right. Okay, so notice now file is not implementing channel. Oops. File cannot be, well, you can, yeah. Sorry about that. There are some safety wheels. So let's see, we got 1, right? That's it. That's the one from there. Let's print something in there. So it works. So you can add these, make these support an interface, even though you define the interface later separately. If you feel like you need to add an interface, you can do that without modifying the existing types. So that's why you don't have to add interfaces until you actually need them. There is no need for that. This comes from a special design of how this works. So it doesn't matter if file is like pre-compiled or something. It can be in a different, it's already pre-compiled somewhere else. It just, you can add these dynamic methods to them and make them conform to interfaces. All right. So let's see if I have any other questions before. No. Okay, then have a nice evening. Have a nice Friday evening. If you're still on Friday, I am now. I'm already on Saturday. Right. Okay. So okay. Good night, everyone. And I'll shut down here.